Very good. Okay, so let's talk about the apps. So I think decentralized applications is something that is kind of natural or seems natural if you look at them. The smart contract itself is something that seems to be very inconvenient. So if you look at, as we did it last week, where I go to my Ether wallet and pasted some ABI in there, pasted some contract address, executed some functions, it was not really good. And the issue is with smart contracts, they don't provide their graphical user interface on their own. Why that's the case? Because that's, it's not essential. So if you would store some information of how to display the UI in the blockchain, this would completely explode and it would require too much data storage. So only the essential functionality of the system is put in the smart contract. So dealing with money, so all these essential issues that you require for, or that you need smart contracts for, obviously belong in the smart contract. But everything else, which is on top, so to say, which is only interface, which is only displaying information, that can be a regular web application and also called a D-app, a decentralized application, as it relies on the smart contract as a decentralized component and is therefore not really so the UI is basically just a view on that, and you cannot really have you don't have any functionality in there. The important part here is also, I think what's interesting is that you could design your interface for any smart contract. So you could go out there, select a smart contract and say, I'm going to design an interface for that. Or there are even websites which basically allow you to, paste your address, paste your ABI here, and we're going to build you a fully customizable UI top from the shelf, so to say. So that's also possible. I think that's cool areas for providing good access to the smart contracts. Because as a regular user, no one would really use this if you would do have something to do with these ABIs. You want a usable interface, and even with MetaMask, it's complicated enough for a lot of people. So we need to make it as easy as possible. And that's what's going on here. So this is a screenshot from the popular CryptoKitties D-app. And that was a hype in 2017, end of 2017, where people bought these cats and sold them for a shitload of money. So I think the most expensive cat was traded for $100,000 on the blockchain because they thought maybe that it would be worth something in the future. I think that's the main use case was, so to say, like investment or gambling on the value of these cats. You could also breed them, so you could combine two cats and get a new one, so to say, and sell these again. So very, very interesting functionality or features there. So that's definitely the case. But yeah, that's the point. So you want to make it as easy as possible for the users to interact with your application. Also, the definition, I think many definitions for the apps exist, and you could also see BitTorrent or decentralized peer-to-peer networks without blockchains as a decentralized application. So Emule or all these other applications could be seen as something like that, or Tor, for example, the Onion router, so this application where you hide your IP address and can serve anonymously, could also be seen as it is peer-to-peer, as a peer-to-peer application. But in our lecture and in our exam, we consider a D-app as a decentralized application based on one of more smart contracts, which is accessible via a dedicated user interface. And I think two properties must hold here. First of all, the core data records of the application must be stored on the blockchain, so all relevant data is on the blockchain. And the functions that change the core data must be executed on the blockchain via a smart contract. So it cannot be some external service that somehow monitors that, or just is in the hand of one single entity. Benefits, obviously, I think that's something that we talk a lot about. Trust, payment, account storage. So trust is obviously very important. You can check any verified smart contract, go on Etherscan, look at a verified smart contract and see that it's there, understand its code. Also, payment is something that is implemented by default. You don't have to have any credit cards. You do not have to integrate PayPal or other payment providers. You can just say, okay, transfer amount or make your smart contract or your function payable to receive money. And I think that's something that has not, it's so easy in comparison to other programming languages, or if you want to run a web shop or something like that, it's so much easier in a smart contract. Also, the account system is there, so you don't need to handle user data, you do not need to handle passwords or make sure that it's correctly hashed, something like that, because the Ethereum account system is already there. You have a storage also. The apps could be used as a data storage, but that's something that's really, really expensive in the meantime. So maybe that point does not apply too much anymore. Okay, the drawbacks are obviously there, so it costs money. And as you saw in the exercise, 3,600 Ether paid this transaction fee every day. So that's really a lot of money. And so that rose a lot in the last weeks. The time also is, so the transaction time is also 14 seconds. So if you want to, for example, gamble on a blockchain, play blackjack or something like that, that isn't really feasible. Yeah. Also, the availability is one key advantage, but however, the availability can also be quite harmed when, for example, CryptoKitties was launched. The network was really overwhelmed a week, so that's a little bit unfortunate there. And also, transparency is obviously, so you need these external parties, this third party here, for example, for Etherscan to get the smart contract source code. So I know there's a lot of research about how can you validate the smart contract in a decentralized way, but there is no easy way to check if a bytecode belongs to a smart contract or a source code without compiling it. So you need to compile it, and that's obviously quite resource intensive. So how is a smart contract deployed on the Ethereum blockchain? I think we covered that already. We write it in Solidity. The compiler produces the bytecode. We send the bytecode, so the deployment bytecode to address 0 into the blockchain, and this is executed, and the result is returned and stored, and this is the actual runtime bytecode. But for you, it's important that basically you need to send the bytecode to the address 0, then it's stored and can be used as a smart contract. So very, very easy to separate here. What's important here is that the left part is obviously only on your local machine and the right part is visible to anyone, but therefore the bytecode cannot be seen, as I already showed it to you. And this is, for example, a smart contract on Etherscan, a verified one. So for example, I can show it to you for a second, I think. Where is my Chrome? We go here and go to verified contracts on blockchain, verified contracts. Then you can look at all the verified contracts that are on Etherscan. Only the last 500 one. But if you click on one and it is verified, then you get the source code. Well, that's quite a large one, but you get the idea here. Get back to the slides here and continue. So let's, I think, take a look at the architecture here. So half an hour left, I think that's okay. The architecture here is, so generally, when we look at web-based systems or the web-based D applications, and then we see is we see a website, or there's this state of the DApps website, and the state of the DApps websites allow us to look a little bit at publicly listed decentralized applications. And it does not only display for Ethereum, but for all other blockchains which support smart contracts here. We can take a look at that. Yeah, so that's basically what you can see here. And you can see that we have a lot of platforms. So Ethereum, EOS, Steam, Hive, XDAI, Neo, so many, but I actually can tell you the difference between all of them. So I'm only familiar with Ethereum. And yeah, there are some kind of weird top 10 lists, for example, but you see, for example, if you look at Ethereum top 10, then the number of the number of users is sometimes a little underwhelming. So 127 people in 24 hours. So I think with the zero amount of transactions, yeah, it's not too much. Okay, continue with the lecture here. That's actually also from the website, some kind of current usage of dApps. And as you see here, this is not too much, and it's not really relevant. And it's also a little bit declining. So in January 18, it was more than in December 19, for example. So yeah, it's difficult to really difficult to to find valid use case. I think that shows. And this is not the amount of applications. I'm sorry, I confused it for a second. It's the active users here. So the amount of users that interact with the one smart contract. But you also think of how is this measured? This is not measured by real users, but this is just how many unique addresses interact with a smart contract. And this is a metric that could easily be faked. And I think I read some report where actually that happened, that people tried to push their applications in these rankings by just creating fake users. So that's definitely the case that's going on here. So let's talk about the architecture. I think that's the most interesting part here, to see how it works in the web. So you have your browser here, and that's your unique browser, and you wanna access some kind of application. And obviously you connect to a web server which already has the information. So some website, some JavaScript on there, and what you get here is you have a private key manager. And this private key manager can be, for example, MetaMask. So that's very important, that you need some kind of key manager that allows you to sign transactions and to issue to your full node, and to access the blockchain, so to say, and the smart contract and the information that's on there. So all that's happened, retrieve straight off the blockchain, broadcast unsigned transaction, register event subscription or something like that. And this key manager basically helps you to get the information on the blockchain. But usually that's the secure environment that manages the private key of your account. So that's where all the magic happens here. And the web server is, so to say, only the provider of information, providing only the nice UI, providing, oh, there is the smart contract at this address, and you can do this kind of functions. So that works very well. But there's also can be more complicated systems where you just say, we have some web server where we can also have a setup where the web server itself has a private key manager, has a connection to the full node, and also signs transactions and communicates with the client, for example. So for example, exchanges do that a lot, because when you talk to exchanges, then you do not keep the money or keep the coins. So they keep the coins for you, or the tokens. And therefore, this is also a valid approach. This also can be combined. So I know an application which basically it's a game, and this game is more or less, it's a simple mini game you can play with against other people, and the web server basically provides you with the game and the interface, and but decides upon the result of the game. So who wins, and instructs the smart contract, so to say, to pay in which direction the funds is distributed to. So this is obviously always a design question of how decentralized your application is, of is it completely decentralized? Would you like to run the complete game on the blockchain, or can you exclude parts? And the good thing here is if you exclude parts, then you're obviously winning a lot in terms of speed, performance, functionality, but unfortunately we lose a little bit this decentralized approach. But obviously the blockchain can provide some security here. So for example, the web server which provides this game can only decide in these two directions. For example, both people put in money into this game smart contract, and the web server can now decide upon this smart contract which of the two players win. But it could not decide, I'm winning. So that's a little bit the security that smart contracts could provide here. The same applies here for MetaMask. So that's, I think we talked a lot about MetaMask and what's going on here. Example, CryptoKitties. So I think that's just slides in terms of how does it work. So you can buy a cat in terms of that. You click on a cat, you press the buy button, and this you need some additional information on CryptoKitties, because obviously there is some other thing like a KYC, also know your customer, or anti-money laundering regulations, which require that you give the data to the owners of this website, so they can prove that they do not launder money. And you get you get to the website. You need to sign the message, obviously, so that you can prove that you actually the party that you claim to be. And then this is regular MetaMask window. So this is as I showed you before. Okay, so let's talk about libraries and frameworks. I think that's the last part that also applies to the exercise that we do not do. That's just optional for you. So if you're interested really in coding and in developing Solidity smart contract, then this is for you. So obviously the deployment lifecycle is out of the Solidity source code, you generate an ABI and a bytecode. And the ABIs, as we knew here, we have this contract hello world, we have this function with this, it returns a byte 32, this byte string here. And we get an ABI, which basically tells us what this smart contract is capable of doing and which functions we can call on. And it also, this compiler provides us with the bytecode. We can use this ABI in a D app or via Web3 with this smart contract address, and use the smart contract which has been sent to the network as a mined contract then. So as I showed you before here on this slide here. I was a little bit too fast. For the local environment, so if you want to develop locally, we only developed in Remix. That's very convenient, very practical. But if you want to develop locally, do a lot of testing, then I recommend different IDE code editors. So you can use Atom, Sublime, Visual Studio. They all supply some code formatting for Solidity. And you should automate your build management with Truffle. So it helps you to test your, to write tests for the smart contracts, to do all your daily builds and integration tests, stuff like that. In the network deployment, you can either test locally on your test network that's provided with Ganache, or you can go to public test networks, as already previously said, Robson, Kovan, Rinkeby, or you can directly go on the main network if you're ready for production. Truffle is the popular framework to facilitate the development of Ethereum smart contracts, and it provides the tool to compile, test, and deploy Solidity contracts. So that's really when you talk to the experts that do a lot of Solidity coding, this is the way to go with Truffle. So that's really it's a command line interface based tool. So a little bit difficult to use, but you get the hang of it, and it's really valuable. And Ganache is, so to say, the local blockchain, test blockchain, similar to what you would receive from Remix in this JavaScript VM. So you get accounts here, and you can copy the private key of these keys and do transactions, do smart contracts. You can inspect the blocks of your blockchain. So if you look here, you can look at the transactions and get information about the system in a very easy way. Online, I think that's something that we covered already with Remix. That works also very well. And I think that's something that we covered already. So that's a little bit outdated, unfortunately. Yeah, and apart from that, test networks, also information about that, but that's also something I think interesting to know. But you need to be, if you don't really find use cases, or when we develop something, that's not really important on which test network we are on. Okay, and the last interesting part, I think, is to look a little bit at Web3, because that's something that allows us really to design the UI. So that's a JavaScript API that allows to wrap this JSON RPC interface. So this what a full node provides, so to say, for your website, and you can easily access data, smart contracts, execute transactions, all you need with this Web3.js. So this is also what we use in terms of when we develop something. And the smart contract part is obviously very small, and also I think from lines of code wise, the smallest part of your project. But with Web3.js, you have a lot to do in terms of, okay, how going to handle transaction, how do you get data, how do you facilitate all that, and let's take a look at how that works. So if you look here, that's a example to get the balance of a specific account within your browser. So you could put this in JavaScript, include the Web3.js library, and actually get the results if you provide a full node here, or in your JavaScript, in your Node.js server. So this is the example for Node.js here, but that also would work similarly in the browser here. So what you do here is you define your Web3 as with this Web3 module that you have to first install with your Node package manager, and then you provide a HTTP provider, so a full node local installation, or for example, Infura.io is a company which provides you with a full node connections, and then you create a wrapper function to retrieve the ETH balance of an account in Way, and what you basically say is get account balance with providing an address. And then you can use this function from Web3 to get a balance on an address. And this Web3 provides thousands of functions that you can use to interact with the blockchain. And this is what actually happens here. So you execute the function, and after this function has executed, you can lock the balance here. So this is Node.js. I would not recommend to learn this for the exam, so that's not relevant. Everything I show here is not important. Important is Solidity and the Solidity development, but we won't ask you anything about Node.js and Web3. Also, here you see sending Ether to another account. You can define your gas price, your gas limit, define the raw transaction with from to, define the private key here, sign the transaction, and actually send it to your full node to make it public in the network and to get the transaction mined. Also, you can reference these smart contracts in Web3 and basically put the ABI in there and use the functions here. So you define the ABI here as greet, and now you can execute this function on this contract, which is also very nice. You just provide the ABI, and then you're good to go to use this in JavaScript, which is very powerful. If that's in the browser, then MetaMask will pop up and ask you to sign the transaction or to confirm that it takes place. Yeah, and the Solidity events. So that's the convenient way to listen for smart contract function calls and state changes without scanning the whole blockchain. And this is mostly used to trigger callback function and DApp event listeners. So basically you execute a function and you wanna be notified when this is done, then your website can basically listen to this event and notify the user when it was done, so to say. The events and logs are expected to change in the future. Currently, there are discussions in the Ethereum community to remove them from the persistent blockchain state. I am not too sure what the update is on this. I did not hear anything about that, so it's still in there. It still works very well. So I don't know what's going on there in this discussion. But for us, I think it's a very convenient way to access information. So for example, we also see the events on these ERC20 tokens. And I think that's very interesting because for a lot of people, that's a very convenient way to track the state of an ERC20 token. So you have let me explain. You have an ERC20 smart contract, which monitors tokens for you. And so it has this transfer function, this balance function, and you want to make sure that, or this smart contract ensures that only the coins exist that that are defined from the beginning on. So no one can cheat, no one can create tokens out of thin air, something like that. And now you want to do, now you are some interested party, say, okay, I want to do data analytics on that. I wanna find out who has how much coins, something like that. And that you don't go to the smart contract and ask the smart contract, okay, how much funds does this address have, and this address, and this address, and this address. No, you go and ask your full node, okay, provide me with all the log files from until the smart contract was created, and then you can go step by step through the log file and see, okay, this amount was transferred to this party and that amount was transferred. And so you have a very easy data structure that you can go through and basically build up the state of the smart contract and who has which amount of tokens. So that's a very convenient way to check for coin distribution, for example. That's what a lot of people do because it's much more easier, tend to actually look into the blockchain and ask the smart contract what's going on here. Also, you can work on these events, you can access these events, and you have 3 types of events that can be emitted. So for example, the data files on each incoming event with the event object as argument. You can also access the changed one, so files on each event which was removed from the blockchain. and removed from the blockchain means that the event was created inside a block, which was later orphaned. So even they account for situations where transactions where blocks are removed again, and therefore you can also keep track of that inside your application. And also an error argument in terms of when an error happens, in terms of something went wrong. And obviously this Web3 is not only available in JavaScript, but it's also available for Python, Haskell, Java, Scala, PureScript, and I bet 1,000 other programming languages. So that's very, very powerful here to really take a look at that and integrate it in any application you like. So the community is very engaged in this part here.